Okay, so we're in Unit 5, and now we're starting to talk about chemical names for ionic compounds. We're going to use ionic compounds for the rest of the course, so it's important for us to understand how we're going to describe the compounds. So when we talk about a compound, we can use one of two things. We can use the chemical name, or we can use the chemical formula. It's important for us to understand both of these. And in many cases, if we have one, we can figure out the other. So the ionic compound's chemical name tells us the ions that make up the compound. So it tells us the cation and it tells us the anion. In the chemical name, the cation is always written first. The name of the cation is the same as the element name. It's not going to change, nothing really happens with it. So magnesium stays magnesium, sodium stays sodium. The name of the cation doesn't change. The name of the anion is always written at the end of the chemical name. So it goes cation first, anion last. The anion has a different name than the name of its element. It's a slight spelling change. The anion name uses the root of the element, but with the suffix IDE. So here's one example. Chlorine is the element, and chloride is the ion. So here's the atom, here's the ion. Very slight spelling change. Most transition metal elements will form cations, and they have more than one possible charge in most cases. So when we write the name, it's important that we know the charge of the ion in the compound. So the names of the cations of these transition metal cations will be followed by Roman numerals. And the Roman numerals will be in parentheses after the name of the cation. This tells us the charge. And it's important because if you have an element that can form two different ions, those two ions have different numbers of electrons, and they're going to behave a lot differently. Here's a couple of examples. For iron, Fe, atomic number 26, it's a transition metal and it can form a couple of different ions. It can form iron 2 plus, or it can form iron 3 plus. These two things behave very differently, so we have to know which one is which. We cannot just say iron. We have to follow the charge in Roman numerals. So what we do is, for this Fe2 plus, this is iron 2. And for the Fe3 plus, this is iron 3. And so this indicates the charge of the iron. It tells me which ion I have. It's going to be important. So when you talk about something like iron oxide, well, there's two different irons here. Iron 2 oxide tends to be magnetic, dark gray type of thing, and iron 3 oxide tends to be the brown crumbly rust that forms on cars and old barns. Two very different things, so we have to know which one is which. Another example, something like Mn2 plus, Mn3 plus. It's a transition metal, it's right next to iron, and Its name is manganese. Manganese is interesting because when you put manganese into a steel alloy, it gets way stronger. So if you want something with like bulletproof steel plating, you want to add some manganese in there and it makes it much stronger. This manganese is manganese 2, and the manganese with a 3 plus is manganese 3. So remember, the cation comes first, the anion comes at the end. You can think about it a little bit differently too. The English language reads from left to right. So look at your periodic table. If you're at home, look at your blue one. If you're in the classroom, look at the one on the wall. Atoms that tend to form cations are on the left side of the table. Atoms that form anions are towards the right side of the periodic table. So if we read left to right, then it would make sense that the cation, which is already on the left, comes first, followed by what's on the right. Writing the cation first every time, it creates a standard and it makes compounds a lot easier to understand. This is standard across chemistry, cation first, anion second. And we don't want to deviate from that because if you start mixing them up, it makes things just way more confusing than they need to be. When you put the cation and anion names together, we get the chemical name for the ionic compound. Some examples. So here is sodium chloride. Sodium is in group 1, chlorine is in group 17, and it forms a chloride ion. Calcium is in group 2, name doesn't change. When it combines with oxygen, it forms oxide, calcium oxide. Iron 3 oxide, this is rust. Iron 2 oxide, this is not rust. Cobalt, which is a transition metal. This is the charge of this cobalt ion, cobalt 2 chloride. Sodium, which always has the charge of positive 1, sodium bromide. Potassium always has a +1 charge, potassium chloride. Or aluminum, which is group 13, it's going to form a +3 charge, aluminum chloride.